So this becomes basically everything we've been working for. Everything we've been working towards as far as congruency statements and all that kind of fun stuff, and how things are going to set up using our progression sheets and everything. It's all going to boil down to this last bit: triangle alphabet soup. Actually, I should say congruent triangle alphabet soup. Here's what I mean. We know now that if you have all of your corresponding parts between two figures congruent, the figures themselves would be congruent. Well, when you're working with triangles, you can kind of whittle that away and not have to have all 6 parts congruent to one another. You could have 3 parts. And this is where this stuff comes into play. What's going to happen is that you're going to be able to show that triangles are congruent via about, 6 of them, I think? 6 different methods. And what I want to do today is kind of walk through you guys just to show you what they look like, not writing out the full-blown definitions because they're dumb, but if we draw pictures, it makes life easier, okay? So, here's what we can do. Side, side, side. If you have all 3 corresponding sides congruent between 2 triangles, the triangles are congruent. Here's what that looks like. One triangle has those 3 sides. Another triangle has those 3 sides. That again. It is quite literally, if you've got the corresponding sides congruent, the triangles are congruent. That's it. All 3 sides. All 3 sides. All right? We'll make a tally list of what we've got. Side, side, side. We have side, angle, side. Ooh. Don't you sass me. Hey, notice, where's that angle? It's between the 2 sides, right? That means it's called included. The angle between the 2 sides that are congruent. Here's what it looks like with the diagram. Whiskey, you were asking a question. I'm sorry, I didn't mean to jump ahead of you there.
So does that mean all the sides and all the angles will be the same?
Once you have, if you get all 3 sides congruent, then all the other corresponding parts become congruent. What's happening here is that, bless you, you don't need to necessarily have to have all 6 pieces congruent to say the triangle's congruent. You could get down to having 3 of them, depending upon what set we have. Okay?
Could you just have said that earlier?
I did say that earlier,
You did?
but we had to get to be able to do this first. So again, this is when you have a set of sides and the angle between them. Okay? Hence, side, angle, side. Side, angle, side. Huh.
Sounds really hard.
It has to be the angle in between the 2. It's called the included angle. Side, 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 angle, side. What's that? Is there more? But wait, there's more. It slices, it dices, it julienne's fries. Is it julienne?
Yeah.
Isn't that just crinkle cut, or is that really thin cut?
No, it's like really thin.
Isn't it Juliet, bro?
We have angle, side, angle. Gee, what do you think that looks like?
So it's angle, side, angle.
So, in a diagram, where is the side? In between the 2 angles, exactly. Okay? The side becomes the included part, not, or in this case. So we have this: an angle, a side, and an angle. Angle, side, angle. ASA. It's convenient that these letters show what the diagram is going to look like.
Can we have angle, side, side?
There is no ass in math.
I was just asking a boy.
Everybody say it with me. All right, it's okay.
There's no
Everybody
ass in
get it out of the way.
I've been waiting my whole high school career for this moment.
Let's just get it out of our
Only
systems.
reason I came to
There's
There's
no
no
ass
ass in math.
There's no ass in math.
There's no ass in math.
You feel better about that now?
No,
All
I
right.
feel terrible.
Way to go. You see what you've done?
So, thank you for asking that.
If you want, you can write that in your notes.
I would write that in your notes. There, please. Explain that. Tell everybody. Speak it to the world. Shout it from the rooftops.
Say it again.
Say it again if you feel good about yourself.
I'll say it again.
That's fine. If you want to,
Can I
whatever.
scream it out?
No.
There's no ass in math.
There's no ass in math. It's fine. Okay.
Whole class whole class got suspended.
Life gives you lemons.
But there is.
Lemonade.
Look, we learned in math today. Now, all right, guys. There's another one called angle side. Angle side. Now, this one you have to be a little bit careful with. It's two angles and then the next side. Now, you have it. It has to be the side that's opposite one angle, and I'll show you how this can get mixed up sometimes. So, angle side. Obviously, you have two angles in a row, and then the next side opposite. Okay. So, if this is the diagram that I'm going to use, where should the side opposite be in the next one? Across from which tick mark? Should be across from a single angle. It can't be across from this one, okay? Because this is opposite that one. I'll show you how it can work both ways. That's one way that could look.
Or you can look at the
Yeah, or you can flip it around, you know, and you can do it where it's, if it was this way, it's still the same basic idea. And then this one just goes angle, side. It's just going the other direction. But it's still, notice that the sides, these corresponding sides, are both across from the same angle. That's what I'm talking about. That corresponding that corresponding side has to be across from the correct angle. So we have angle, or side, angle, side, angle.
What?
Whiskey, what do you got?
What can we have two A's in one side, and what if we have one angle in two sides?
Well, what happens is you get.
Stop trying to beat around the bush.
No. It's a very what I want to do probably Monday. I'm thinking we might do this Monday. I have this. Seb and I came up with this lesson to show why all the congruencies work that we use with the calculators, with the computers. And we have a website and we have this format that we go through how we can manipulate and move things through. So I can show you how it doesn't work by creation. Now, when you get to Algebra 2 next year, there is what we call an ambiguous case of the law of sines that deals with angle, side. This does occur from time to time, but it is an upper level math thing that you'll worry about later on. For us, there's no ass in math. Next year, you might have a little bit, but not proof, okay?
Don't say that to your algebra 2 teacher.
Unless it's me.
I told her about that ass.
So there it is.
You just walk in.
Last one.
So how's that at?
Yeah, last one we're talking about today. The very last one I'm going to talk about today is called hypotenuse leg. What kind of triangles have hypotenuse? Right triangles. Hypotenuse leg is only with a right triangle. Now, it doesn't mean that every time you see a right triangle, it's going to be a hypotenuse leg, but this is the only time that this does occur. Okay? Here's what happens. In a right triangle, we all know that you have what angle?
Oh, 90 degree.
Where is the hypotenuse located in a right triangle? The long side, opposite the what angle? The 90-degree angle. That's my hypotenuse, okay? Now, what are these two sides called? I think it's hypotenuse. Hypotenuse. The hippo, yeah. Or hype, it's even easier. Now, remember, when you're dealing with right triangles, you always have the hypotenuse. The hypotenuse is always the longest side length, and it is always across from the 90-degree angle. The other two parts are called legs. Now, each leg, it doesn't matter which one you call a leg because they're both legs. What's going to happen is that they have to have some sort of correspondence. So if I happen to say that this one here and this one, I get what's called hypotenuse leg. It has to match up. It doesn't happen we don't see this very often, but hypotenuse leg can only occur in a right triangle. Now, if you look at that, what is that?
It's a triangle.
Side-side angle, otherwise known as? Right. But we don't call it that because this is a hypotenuse and that's a leg. So this is the only time this occurs. It's called hypotenuse leg. Now, what else happens with a lot of times within right triangles is that you do wind up with these you get an angle to match up rather quickly. Okay. What's that?
You just made ass when you said there's no ass in math.
Right, because in this case it's not that because it's called hypotenuse leg. And this is the only time that this can occur is if it's a right triangle. Any other time you see two sides in an angle, it doesn't work. Okay? This is, like I said, I'll show you guys how all of this is going to work through as we get into the computer programs, probably my best guess would be on Monday. Okay? Let's look at some examples. Get you guys this old-fashioned worksheet here for this notes. What's that?
What's it say?
I told you we were done by
This class, I can't stop. It's probably gonna happen like right when we're out of college. Well, we just created some new
I didn't read it yet. I would imagine it's fine. That's awesome. That's great. So, let me pull this up here too.
How many do we need?
Thank you.
Might just take an extra one, just because.
By all means. So here's where this stuff is going to start to play itself through. What we're going to have to be able to do here in a lot of our diagrams is that we're going to have to come up with a way to show that the triangles are going to be congruent. Now, eventually, we will start to do this with proof. We will start to use our progression sheets again by going through there's something to midpoint, we have a reflexive side, things like that, vertical angles and whatever. But for right now, what I want us to get in the hang of doing is looking at a diagram, seeing what else you can mark up in the diagram, and then determining which of the 5 possibles we could use. So in this number 1, what one can you throw out right away? Hypotenuse leg. And why can I throw out hypotenuse leg right away? There's no right angle. There's no right angle shown. I can't assume that there's a right angle. But I do have one thing. Now, I'd like you guys to have your progression sheet out also, because I want to, if I need to add something, which I might. Don't throw that thing away. Hey, if you guys need fresh sheets and whatnot, I will get some more copies made so you guys can rewrite them and whatnot, or find somebody that has a nice one and copy theirs through, because you will be using these still, okay?
That's my only.
And right off the bat, with this very first example, I'm going to put a small little reminder. Yeah. What I want to do here is say, look for what's called a reflexive side. Bless you. Yes. The reflexive side is a side that's shared between 2 triangles. Leave a little bit of space, because I'm going to add to that later on about how you write that in a proof, but I'm not going to worry about that right now. What I wanted you guys to say is, look for what's called a shared side. Because if something is shared between 2 triangles, isn't it congruent to itself? So if I'm looking at on number 1 here, see this side right here between the 2? It's overlap between 2 triangles, so isn't it congruent to itself? That means I can put tick marks on it, because it's reflexive. It's shared. So by doing that, what do you get? SAS. You have side angle side. That's what that looks like. Now, if I was given those bits of information, in a proof, all I would have to say is, let's say that I'm segment BD. BD is congruent to BD because reflexive. And then I'd have congruent triangles. Yes, ma'am?
Is there ever going to be an angle?
No, there is not an angle, because what happens with angle, you can have 3 triangles that have, or 2 triangles at the same angle measurements. This is a great question. Think of a, what do you call it? What is it called? The equilateral. That's this one, right? Yeah. An equilateral triangle has all 60-degree angles, correct? So if I say this is equilateral, all 3 sides are the same, all of these are 60. You'd have that for this one, but what happens with this then? See what I'm saying? That's still an equilateral triangle because all the angles are 60, but they're not necessarily the same side lengths.
They'd be similar.
They're similar, very good. What happens here is you get similar triangles, which we deal with middle of December. All right? It's a great question.
Middle of December?
It's not that far off, man. It's crazy, isn't it?
Long time.
It's not that far off.
This
Hey, take a look at number 2. What are you going to do in the diagram of number 2? Yeah, I'm going to make that diagonal congruent to itself because it's shared between the 2 triangles. Everybody see that? What do you get? Side, side, side. There's no angle, so don't sass me. You have side, side, side. Everybody see that? Okay. Now, what about number 3? What do you get? Angle, angle, side. Angle, angle, side. See how that works?
No, I can finish this last when you get card.
Well, you probably know that already. All right. Let's take a couple of minutes on your own. Do those real quick. Okay? Go through. Mark that's what you did. Now, one of the things that you guys might have been able to notice is that there are going to be times where you can use multiple setups. There are more than one ways to show these things sometimes. Mr. Pitts, go have a seat. What do you do in the first one on 4? Shared side. You've got this shared side here. It's your reflexive side. So what is that then called? Angle side angle. What about on 5? You've got the shared side again. You've got that reflexive side. Gee, is that going to be a pattern for a lot of these? Sure. Side angle side. On 6, what do you have? There's a bunch of different ways you can do this. You have a shared side. If you threw the shared side in, you could have side, 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 because you've got all 3 sides. Or you could have done side angle side, because you've got that one in between them. Or you could have done hypotenuse leg, because you had the hypotenuse and a leg with right triangles. Now, this goes back into the idea that there are going to be more than one way to solve these things, depending upon what information you're given and what information that you guys see to the diagram. But as you can see, with a lot of these, there's not much there, okay? A lot of this is going to stem from your progressions that you have and just the importance of marking your diagrams. Yes, sir?
So like on the test or quiz, you want us to come up with all 3 of these?
It depends on the question.
Oh.
I might say list all possibles, or I might say list in what way could you show. And if you just said side angle side, that's fine, because you're right. But if I said list all possible ways you could show, then that means you'd ask all 3. It's a kind of a loaded question. What about in 7? What do you have? You do have hypotenuse leg right away, because you've got right triangles. The hypotenuse and the legs are all set through. What's the other way? Side angle side. Where is this angle? If I say the 90 degree angle is not between the 2 sides, because now all of a sudden you've got side angle, and we all know that there's no. But you've got vertical angles though. In this case here, you've got the idea that you can have vertical angles. Now, on your progression sheet, there's a diagram picture. It says, look for vertical angles. This is a great example of when you have vertical angles. So this case, you could possibly have hypotenuse leg. You could have side angle side. What's another one you could have? Nope, I don't have that 3rd side. Angle side angle, angle side angle. You could also have angle in that case. Okay? It depends on how you see that as you go through with your vertical angles. Right? What about 8? What do you get? Good. You got your angle side angle again. And then last but not least, what do you have there? Side, side, side. Okay.
Wait, number 8 is A.
Yes, you've got angle side. I didn't write that down.
And then Mr. Murphy, for number 9, because it's an equilateral or equilateral triangles, that's also equiangular, could you even say?
We don't know if it's equilateral. We don't know because these two are definitely our isosceles.
Okay.
So we don't know that.
Okay. So we're skipping this side.
Yeah.
All right.
And I think the last 3 on there got cut off because you're right, it's an old-fashioned meal crap. You really can't see most of it. So let me give you guys some of this style problem for homework, and I think you probably get most of it done before we walk out of here.
I think that's algebra 1, 2, 3. So it's social. Brandon?
Oh, I didn't do that. This was for you guys for your just for notes and stuff. I just forgot the whole budget. So if you guys want, there's a whole bunch lying around.
What?
You guys are plans. I know some of you can see on some of the copies you can see it. Yeah, by all means, I apologize. I forgot to make a whole bunch of those. If you want to save those, the whole bunch back here yourself. Now, guys, on this one here, I'm just asking that you guys go through. There's only 3 of them here: side, 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 side angle, side, and angle, side, angle. Now, you guys know about the other 2. You know angle, angle, side, and hypotenuse leg. So it is possible that some of them could be shown that way as well. Now, there is also a possibility that they do not work out to be congruent. One thing I want you to look at is that you have to come up with an idea of how can you mark your diagrams correctly. For example, I'd like you guys to look at number 11 real quick. I'd like you to look at number 11 real quick. On number 11, you're given sets of parallel lines. Now, one of the things that we know about parallel lines is that we look for angle pair relationships. Do you guys remember those? Two parallel lines cut by a transversal, you get certain things congruent. Now, if I take my paper and I twist it sideways like this, it now looks like how we drew out most of our diagrams before. Is everybody okay with that? So I have two parallel lines cut by a transversal. What do I know about angle CAB and angle TBS? They're not right angles, we don't know that. But they're congruent because what angle pair relationship are those two? They're in the same side. Very good. Those are corresponding. When you get parallel lines like this, you're going to want to go through the diagrams looking at, because you have your examples on your progression sheet of what the angle pairs look like, to go back and forth to figure that out. Same deal going here. Here's my other parallel lines. I know that angle TSB and CBA are also what angle pair? Same side, same position. They're also corresponding. Now, I'm not going to lie to you. You're going to see this diagram drawn like this a ton of times. And if it's drawn like this in any position like that, you wind up with corresponding angles each time. Because that transversal is like a base of the triangle then. So how do I show that, how can I say that these two are congruent? Which of the... Well, we have angle, side, angle. Angle, side, angle. So this would be congruent by... Please mark your diagrams as you're doing these things to help show what's going on. That's the easiest way to do these things, okay? Nick? Very well.